Okay, this is a different type of induction question. It's one where we want to prove that a given statement is divisible by a number. So again, the process stays the same. Like we assume we show it true for the first number, and it's n is greater than or equal to 1 in our definition, so we're showing it's true for n is equal to 1. So 3 to the power of 1 plus 1 is equal to 4, which is divisible by 2. That's all good. So as long as we come up with a number there that's divisible by 2, then we're in business. So it's true for the first number in the series. Now we're going to assume that n is equal to k. Now this is where it's a little bit different. So what we're going to say is that if it's going to be true, the 3 to the power of k plus 1, so we're substituting k n and putting in k there. When we get that statement 3 to the power of k plus 1, divide it by 2, so if it's divisible by 2, we get some number m. And m is going to be an integer, and we're going to define that. We're going to say, well, it's going to be equal to some integer m. Now we can leave it like that at the moment, or when I do these questions, I like to just manipulate them. And because I wanted step 3, I'm going to substitute something from step 2. So usually it's going to be a manipulation of our algebra, and I've just multiplied by 2 on both sides to get 2m. 3k plus 1 is equal to 2m, and then 3 to the power of k is equal to 2m minus 1. You can leave it like that and then manipulate it later on. It's up to you. So in the next step though, what we want to do is prove that when we substitute n is equal to k plus 1, so if we get this statement, again we're going to get that this statement can be divisible by 2. So that's we need to be able to get that in there. And we're going to have to manipulate it because 3 to the power of k plus 1 can be written this way. So we need to get rid of the 3 to the power of k because we can't prove that part is going to be divisible by 2. So we manipulate it 3 times the 3k, so we're playing with our indices here. And now we can manipulate and put in 3 to the power of k. That we know that was equal to 2 times m minus 1. Now m's going to be an integer, so m's a whole number. So we expand this out and get 6m minus 3 plus 1, and then 6m minus 2 gives us a factorization of 2 outside of 3m minus 1, which means that because we've got 2 times some number here, and m's an integer, so that whole number must be an integer, that whole statement now is divisible by 2, and that's our aim, is to be able to factorize the 2 out, or the number that we're trying to divide by out. Our step 4 follows exactly the same. So have a look at it again. So n is greater than 1. We want to prove that for any number we put in for n there, it's divisible by 8. So we put in n is equal to 1, substitute 1 in, and we get the 9 minus 1 is equal to 8. Well, obviously 8 is divisible by 8, so it's true for the first number. Again, we assume n is equal to k is true, so 3 to the power of 2k minus 1, divide it by 8, and that's going to be equal to some number m, where m's an integer. There. So again, I'm going to manipulate mine down. So I'm going to get 3 to the power of 2k minus 1 is equal to 8m, which I can write as 3 to the power of 2k equals 8m plus 1. So again, any manipulation you like there. Because what we want to do again is prove when we substitute n is equal to k plus 1 into that statement, that we can get it down and be divisible by 8. So again, I really want to manipulate it and get rid of the 3 to the power of 2k because I'm not sure what that would be divisible by. So and that's what I want to manipulate out. So again, I'm playing around with my indices. 2k plus 2 just by expanding the brackets, which is the same as 3 to the power of 2 times 3 to the power of 2k. Decompose that. So it gives me 9. Now, the 3 squared, sorry, gave me 9. 3 to the power of 2k is equal to 8m plus 1. Do that manipulation. Now I've got this number, which is going to be an integer. 8 times an integer plus 1 is an integer. That makes it nice. But it's not necessarily divisible by 8 there. I haven't been able to factorize an 8 straight out. But if I expand it out, collect my like terms, I can factorize an 8 out nicely, which leaves me to 9m plus 1 divisible by 8. So we've been able to prove that this statement here, by manipulating it into a form that we can see, is divisible by 8. And that's what we've got to do with all those questions. Manipulate it, getting that step 2 in there, and getting basically rid of the 3 to the power of 2k because we're not sure what that is.